Okay, this is lab 1, your 4-bit adder. This will be week 2. Some of the folks that may have their part list shipped, it may come in during midweek or end of this week. So there'll be some extensions on this lab. Okay, and you also can do the simulated version of this 4-bit adder as well. Although there'll be 2 different integrated circuits, or MSIs, so you have to be very careful where your VCC, your power grain pins are as well, so that you'll know what pin out it is. And we'll go through that. So essentially, we're going to be able to test the binary addition, which you have just kind of learned in chapter 2. And you'll be looking at the carry in, and this could actually come from a different or the same 7483, so you could cascade this. And likewise, the C4 would be the out to the next 4-bit. So you could really expand these and scale these out to all the way up to a 32-bit adder as well. Here are some of the student learning outcomes, and these are compliant to our course learning outcomes, as well as our PLOs and our what we call our performance indicators. Okay, so carefully look at that. And what we do, we are part of the 8-bit. This is the engineering accreditation. And we'll be using or aligning the outcomes with these 1, 3, 5, and 6. And you can read a little bit more about that, but your rubric will be based on the standards from the 8-bit. And that'll be something we'll discuss later too, just as you are about to submit the labs, okay? Again, as I noted, you can do the multi-sim as well, which would be fun, and I'll show that in a bit. But when you do the multi-sim, the multi-sim has a different, well, it's the same 4-bit adder, but the pinouts are different, so you got to be careful. A lot of students don't look at that. That's one of the first things we ask students, is to look at the data sheet to confirm the pinout. So that's kind of going to be a good exercise for you to do. So these components here are all in your kit. If you have your home lab set up yet, maybe not quite, all these parts should be available in Open Lab as well. So again, for your dip switches, you're going to be the onboard, use the toggle switches and the LEDs that are on the trainer board. You don't actually need to install any of the LEDs, okay? The trainer has the power supplies, and you should have some jumper wires. You can get those from Amazon. I did list those. Again, the kits don't have any wires. All they have is the components. Okay, and if you have a DVM, the DVMs are digital voltmeters. They're pretty inexpensive. You can probably pick one of those up. Again, this is for your home lab. Okay. So again, as I noted, you want to be able to look at which of the ICs you're using. So it's going to have different pinouts. So you want to look at pin 5 for one device and pin 12. Let's go down here real quick to look at the 2 different types of MSIs we're using. So you've got, this is probably the one that's in your kit. You need to check. There's a little notebook if you go to Open Lab. They may be using this full bit, but the one we're using in the simulated version is this one. So the pin out, you can see the sum bits, and also the A registers and the B registers are different, but the functionality is the same, the digital logic functionality. Okay, so back up here. Again, you got to carefully review the data sheet to confirm the pinouts. Okay, that's on you, and that's what we want to encourage you to start reading the data sheets for both the DC and the AC parameters. But for now, just look at the functional pins. Okay. So for one version, the registers are going to be on these. Now carefully look at this. Sometimes my TA may make a mistake, and sometimes that's a good too. So you want to double check everything. Okay. And again, you don't need to use this because you have the trainer, and you can. I mean, the current limiting resistor is okay, but it'll be okay. You're not going to be driving a lot of current out of these LEDs. Okay, so let's look at the modes here. This is a test table that you're going to need to confirm. So here is we have a binary 5 and a binary 3, right? So when you add that up, that's going to give you some value, right? So you need to fill that out. And let's do a few of these right now. I'm going to stop the video and I'm going to jump over to multisim real quick.